So, hi everyone. Thank you for joining in. I'm Arjun, your host for today. As for today's session, we're gonna learn more about how to implement interactive live streaming in Flutter using the video SDK. So, before jumping to that, let me give you a brief idea about what is the interactive live streaming and what kind of problem we're trying to solve with the video SDK. So let's first understand what is the video SDK and why we have built this solution for the developers. So video SDK is a live video infrastructure for developers. Basically, I'll start with the couple of things, the problem statement that we have been trying to solve. If you see, in last couple of years, it's pretty much easy for anyone to go live at any point of time because of great network capabilities such as 5G deployment, fiber to home, accessibility of high quality cameras, such as really good camera in your mobile devices, as well as launching of new video devices such as AR glasses, video desk phones, cameras in wear headset, or just camera in the smartwatch. This all cameras helping people to go live very easily uh, and very efficiently. Apart from that, if I'll consider the point of view of audience, people are watching this live streaming. We as a human being are highly visually creatures, and we love to replicate the real world virtually. And you can see a lot of things around you. It could be collaboration, it could be meetings, it could be streaming sessions, or it could be anything. We love to do it online. Apart from that, these modern devices are becoming our organ every day. So we cannot live our life without our mobile devices, our laptops, and all other devices, powering real-time engagement and collaboration. And if you see, one of the common part of all these devices is video. We all are, consuming a lot of video content on everyday basis. Now, for the next part, if you see the traditional live broadcast, like cricket matches or soccer matches, there used to be time when there was one broadcast and millions of viewers. Because of the social media and all these devices, now there are millions of people are going live and millions of people are participating in it. It's making sure that the future of video is more immersive, more interactive. It's built for better engagement and collaboration. And each and every consumer product is doing the same thing. If I consider the Instagram or YouTube's of a social media, or Meta or Twitch, or just gaming, Roblox or Fortnite, all of them are providing either voice, video, or collaborative features for people to go live and engage with each other. But the problem is, it has been pretty much hard still for developers to build such kind of live products. The reason is pretty simple. It takes months to build with different kind of tools, services, platforms. It's not optimized for all the devices, all the operating system, all the browsers. There's a high latency across the globe when you're, building such kind of solution. It's a complex billing cycle while you're scaling all this stuff, and it's pretty much less customizable. And specifically, it does not have a flexibility to deliver a great experience to the users. That's where developers are struggling a lot to build such kind of solution specifically. And to solve this problem, we came up with the video SDK. Video SDK helps developers to build real-time engagement, real-time collaboration, and real-time video altogether with just line of codes. It's easy to integrate, it's cross-channel, it's cross-platform, and you will customize it as per your need. Apart from that, you don't have to worry about compatibility and the scale or reliability. We handle that specifically for you, so you just can focus on the other problems. Video SDK does have two major products. One is the audio video conferencing solution, which provides you a 300 plus participant, completely real time, less than 90 ms global latency. It does have a really good cross device support, high bit rate and frame rate, and you can also build a collaborative features on the scale using the same solution. Apart from that, on other side, like we provide a millions of participant support with the interactive live streaming. It does have a 3 to 8 seconds of delay, but the thing is, it's much reliable than the any other solution available of the market. The reason behind it is like we are using the native codec, which is supported by 98% of devices. It's adaptable as you know with the resolution and bitrate based on the customer's resolution and internet bandwidth. Does provide you a post streaming support, so multiple people at the same time can go live. It's It does have a feature of playback and output as the RTMP or HLS. So it provides a very reliable experience of playing back video. If I'll talk about the couple of features of video SDK, interactive live streaming is one of that is post streaming. So at any point of time, you can ask any of the person to come on the stage and speak specifically, even though they're you know uh, around the world somewhere in a specific location. The next thing is that you can also customize your experience specifically with the video SDK. So let's take an example that you wanted to change the background while going live. You wanted to put a lower third or a title, or you wanted to invite a couple of more people while going live. It's all possible. Not just possible with the static template, but you can dynamically change it on the fly. So you wanted to keep one participant on the spotlight, another one in sidebar with a small window. That's 100% possible. Another feature is high quality live streaming experience. You can have thousands of viewers with a very less amount of frame drop rates, as well as a pretty much high bit rate. It supports desktop, iPad, as well as mobile, all the mobile devices, and it adapts the resolution and bitrate accordingly. If I'll talk about a couple of use cases of interactive live streaming, one of the major use cases gaming, experience of the game, as well as inviting couple of gaming creators to join in one single window at the same time interactively going live with the game experience. Apart from that, couple of more interactive features like chat, poll, all this thing you can build with use of one single SDK. Another use case is the live commerce or live shopping. At any point of time, creator wanted to go live, engage with their audience via chat, gifts, as well as providing them the support of buying these products natively in the application. That's 100% possible with the video SDK. The another use case is education. If you wanted to go live with the thousands of students, as well as you wanted to build interactivity of a poll, chat, or maybe a whiteboard. With the video SDK, it's pretty much easy to build such kind of features. So that's it from my side. The next is Rajan is leading our Flutter development in the video SDK. He'll explain the implementation in brief detail. Over to you, Rajan.
Hello, am I audible now? Okay. Myself Rajan. Um, I'm a Flutter developer at video SDK, and let's get started for building the live stream app using Flutter. So first of all, you have to go to docs.videosdk.live. You can select our Flutter SDK and head over to start with interactive live streaming. So before building the app, let's just have a brief overview of how the app would look. So basically there would be a joining screen with 3 buttons where host can create a new meeting or just provide a meeting ID and join it. He would be able to see all the participants, all the hosts present in the screen in the meeting, and he would also be able to toggle his mic, camera, and start and stop the live stream as and when needed. Whereas when a viewer joins, he will be able to just see the complete live stream in a video player. So without any demand, let's just get started. So we will create a new Flutter project. Create Flutter project. Created. Let's open it in a VS Code. You can see my project is ready. Next step would be to install our video SDK in it. So let's run Flutter pub add video SDK in it. You can see video SDK has been added. We need 2 other packages. One is HTTP, which will allow us to add API request for creating the meeting. So let's install it. And next would be the Flutter VLC player, which will allow us to play the HLS stream that we will be showing on the viewer side. You can also use other players like player provided by Flutter, which is video player, but it doesn't provide you very much customizations on the UI front. So we will be using Flutter VLC player for that. Let's add it to our project. Okay, now we are done with all our dependency installations. So this would be a project structure that we would be following. We'll be creating multiple widgets in it. One would be one file which will have all our API calls. We would be using create room method to create a new meeting. ILS screen dot will contain a widget which will dynamically render if the participant is in viewer mode or in conference mode. These two are responsible for showing the UI for speaker view and the viewer view respectively. Join screen would be the screen that you can see over here, which will create show us the buttons through which the participants or viewers or hosts can join the meeting. Live stream player dot will be a widget which will be responsible for playing the HLS stream. These meeting controls would be these 3 buttons that you can see on the bottom of speaker screen. And participant tile dot would be the widget for each participant's view or each speaker's view that would be displayed on the speaker side. So let's first set up the project with the permissions that we need to run the video SDK, which will include camera and video permissions. So let's update the Android manifest file and add the permissions in it. And also we need to update the minimum SDK version to 23. So for that we will update the build.gradle file, set the minimum SDK version to 23 and target SDK version to 31. With this, Android setup is done. We need to add the same camera and microphone permissions to our iOS setup as well. So let's update the info plist file. The minimum iOS platform version should be 12. So let's update the pod file and make the version to 12. With this, our iOS setup is done as well. So let's get started. First, we will be building this join screen and creating the API request, which will help us getting a room ID. So let's copy this code and create the API call first. As you can see, we need a token to access video SDK APIs and to run a meeting. So first, let's see how we can generate a token. So we will go to app.videosdk.live, which is video SDK dashboard. From here, we will go to the API keys section and we will generate a new token from here. You can set any expiration time, but it's recommended that you use a shorter period of time, and when going into production you use your API servers or backend servers to generate this token. Let's update it over here, and with this we will be calling the rooms API of video SDK to generate a room ID. Next, we will be creating the join screen that we saw earlier. Let me copy this code from here, and I will be creating a new join screen.dart file. It will help our join screen widget. So it basically has two buttons: to join as host or viewer, a button to create the new meeting, and if you want to join as a host or join as a viewer, you have to provide a meeting ID in this text field. When we click on join meeting or create meeting, we will take the user to ILS screen widget, which will take meeting ID, token, and mode of the participant, that is conference or viewer, as parameters. So let's create a new widget, ILS screen.dart. It would be a stateful widget. Which will accept meeting ID, token, and the mode of the participant. And complete our import for this. With this, our join screen is ready. So let's just run it on a test device. We need to update the main.dart file to set uh, join screen as our home. As we can see, our home screen is ready with 3 buttons and an option to enter the meeting ID. So now let's create the first speaker side implementation and implement the ILS screen. So the first step is to create a new room. So let's first declare the state for the room. Now we will create a new room using the create room method. Once the room is created, we will add meeting event listeners, which will give us the information when the room is joined and when the room is left. So let's add this. And we will call it once the room has been created. And next step would be to join the room. So for that, we will call the room.join method. Now we will be rendering the view of speaker if the mode is conference, and we will be rendering the viewer view if the mode is viewer. Let's update this. We will also make sure that room is left if a back button is pressed. Now let's just create an empty widget for now for both of this. Both of these widget will have the room as an parameter for the widget. Similarly, we will create one widget for viewer side. Similarly, this will also take room object as parameter. Let's finish the imports for this. And now we will implement the speaker view as shown over here. So as you can see, we have two widgets over here, participant tile and meeting controls. So let's create this widget one by one. So implementing the speaker view. First, we will create the participant tile. This participant tile widget will take the participant object as parameter, and we will render the participant stream using an RTC video view if a video stream is present. Else we will just show a placeholder showing the person's icon. And next, we will be needing the meetings control, which will have all the three buttons which a speaker will need to interact with the meeting. It will take three callback functions, one for each: to toggle the mic, to toggle the camera, and to start or stop the live stream. It will take the current state of the HLS or the live stream, which we will use to show the proper messaging on the button, like start HLS, or it's starting, it's stopped, or it's stopping. Now let's just add these two widgets in our speaker view. So first of all, we will create these states which will hold the values for all the participants that are present in the meeting. the initial webcam and mic state, and the live stream state. We will initialize the states from the room object that we took in the constructor. We will update the participants list from the room object and also the live stream state from the room object. Now let's add the event listeners for the meeting, which will update the state of participants whenever they enter the room or leave the room. So let's say if a room has started and new participant joins, we will add it to the list that we have stored here. And now we will render a grid using the participants list that we created and the participant tile widget and the meeting controls, which will enable and disable the mic or disable and enable the camera and start and stop the HLS. Let's add the imports. With this, our speaker view is implemented. So let's give it a test run. So here is the view. Let's create a new meeting. It's saying joining. And now it's asking for the permission for audio and video. With this, the conference for the speaker view has been established. Now let's implement the viewer view. So for that, we will first declare the two states, which is the state of the live stream and the URL through which we will be able to play the live stream. So we will declare those state and initialize them from the room class that we took in the constructor, HLS state and the downstream URL for it. Next, on the viewer side, we will show the live stream player if the downstream URL is present. That is, if the HLS is started, we will show the player, else we will show a message that the HLS is yet to be started. Also, we will have to add event listener for the state change of the live stream. So we can update the state. We will receive an event named HLS state change whenever the live stream state changes from stop to starting or it's playable. So whenever the HLS is playable, we will update the downstream URL with what we get from the video SDK. And if HLS has stopped, we will not get a downstream URL, so it will set it to null, so we can stop showing the player. Now let's implement the HLS player, for which we are using VLC player. We will add it here. We are declaring a controller for our player and initializing it with the downstream URL that we get from the video SDK. And here we are rendering the video player. We have set the aspect ratio to be 9:16, so it covers our complete screen on the mobile. So let's complete the imports here. With this, our live stream on the viewer side has been completed. So let's run it on one of the iOS simulators. So let's join with the meeting ID that we see here. With this meeting ID, we will join as a viewer. As you can see, the live stream has currently not started, so it's showing HLS has not been started. So let's start the HLS. It's showing starting HLS. So our live stream is starting right now. And now we should see a player over here once our HLS live stream is playable. We can see the live stream player on the side. This is how you can implement a live stream app using Flutter and Video SDK. If you want to build a more engaging UI, you can always visit our code samples where you can find the HLS code sample. Where we have provided a complete sample code with great UI for you. Thank you. If you have any questions, we can get ahead with it. We have provided a complete sample code with great UI for you. Thank you. If you have any questions, we can get ahead with it. So thank you everyone for joining us on this live stream. We frequently support all the new Flutter releases, so you won't have any problem with Video SDK once you update the Flutter versions. We regularly update it. It's great to hear, Vinod. Yes, Video SDK will support on all the platforms, including web and mobile devices across Android and iOS. We will soon be taking up Flutter support for web and Mac OS as well. So stay tuned for that. Thank you, Mark, for your compliments. Yes, we will surely keep you updated on Discord, Binod. Okay, everyone. Thank you. Yes, you can use Video SDK to live stream your games as well from the mobile. You can use 2D metaverse, I guess, but you might have to use some different library of ours, maybe JavaScript, to render out the complete on the metaverse. Okay, everyone. Bye. Have a good day.